having two or three crores, right? But three clusters. But for example, in particular time, maybe Sunday evening, I would be running a job which needs a lot of resources, especially,
Yeah.
right?
Yeah.
So will what I as I know is AWS will auto scale its capacity whenever it is needed. They will charge us. There is an option like that. So whenever the resource your job needs more resources, AWS will provide the required resources, and it will charge. Whenever the load reduces, it also pull back. That is how
Yeah.
I saw. But the Snowflake, you mean to say we have to monitor and we have to profile it once everything is ready in the production. After that, we have to manually do it. That is what you were saying yesterday, right?
Yes, yes. So what I mean to say is, uh, see, firstly, we will have to understand one thing that, okay, for example, I'll give you an analogy. For example, we buy something from Amazon, whether it's an iPhone or any other product. So we are interested to deal with Amazon. Okay, it is the responsibility of Amazon to deliver us the required product and do the payments and all that. We are not bothered from which manufacturer it is going to get it for us. Okay, so similarly, as far as Snowflake is concerned, so let's consider this is a cluster and which has two nodes, which means it's of small size, right? So say initially we configure the virtual warehouse of say a small size which has got two nodes and one cluster. So behind the scenes, we know that when Amazon, I mean, when we are hosting this on Amazon Web Services, behind the scenes, we know that it will be provisioning the EC2 instances. Okay, but as a Snowflake user or the one who is working on Snowflake as a developer or a tester or an analyst, he is not bothered about what service is going to be used, at the back. So firstly, that we have to be clear. So we are not interested, nor do we have control to choose the type of EC2 instance. Okay, so there are T2, T3, and multi-core and all that kind of M1, M2 kind of EC2s, right? So we are not bothered, or we don't have control also, nor do we get to know also. We just configure this in the beginning of a virtual warehouse as per our research for that particular workload. Okay, so we say, okay, this is going to be a data load work. This is my data load, which is going to happen every daily. And for that, I have come to a conclusion that I need one cluster, or maybe let's take a better, I mean, not better, I mean, let's take a more complicated example. So we say that, okay, for our data load, we decided we will need two clusters, small size. Okay, which means small size means two nodes per cluster. This is per cluster. Okay. So this is what we decided. So, but now now what happens is it will, as far as your data loading is concerned, for example, if it is not required to use both the clusters, the data load is such that I don't need to use both the clusters. So Snowflake will automatically handle that. It will not spin up both the clusters and say, okay, even if this is not being used, let it be on. It will not do that. If only one cluster is capable enough to do your data loading, it will simply switch that particular cluster on, or you can say it will provision only that much. Okay, so that is what is meant by automatic scaling up and down. Okay, but you are saying on a Sunday, maybe there is a heavy data load where even these two clusters are not able to manage it. That's what you are saying, right?
Exactly. Yeah.
Correct. So that time you will have to go and manually resize it, or increase the cluster. You will have to go and manually say, see, this is kind of a there's a slideshow here. This is a kind of a configuration or setting you are doing while creating a warehouse. Okay, so warehouse is an object in Snowflake. So you, like how you create a database, you write create database dev underscore db. That's the way you write it, right? So similarly for warehouse also, you will be creating it using a database command. I'm not database command, SQL command, saying create warehouse with so and so configurations. Whether you want X small, whether you want small, medium, large, up to you as per your research. Okay. But even then, if you're saying, okay, on weekly it was running fine, but on Sunday, the data load was heavy and this was not able to handle it. So you will have to, so what do we do when we want to add extra columns in database, in tables or views or, such, we do alter on that object, right? So similarly, we'll have to do an alter on the warehouse for the size. That will be manually. You will go and say, okay, this is not able to handle my data load. I want two more clusters. Okay, so what Snowflake will do is it will add two more clusters, but that you will have to manually say. You will alter it. So it will give you two more clusters. So this is called as, so automatic scaling is when you already have configured it among those pre-configured clusters only. It will do automatic scaling of clusters up and down either way. But if you need more, you need more resources. So that could be either in form of clusters, like you need two extra clusters, or it could be either resizing of the existing cluster. For example, I don't take these two clusters. Okay, I say resize the existing clusters. So that way I will alter my warehouse to the new size. Now it is small. I will say, okay, make it medium. So when I make it medium, it will add two more clusters to these, two more nodes to these two clusters. So that will be manual if you want to increase it. But what I mean by saying automatic is that this is your pre-configured two clusters with two nodes. In this, whatever resources is required, only that will be used. And automatically, it will scale up as per the load increases and it will scale down as per the load decreases. Did you understand now?
Yeah, I got it, Abdul. You mean to say the scale up and scale down are limited to the resource which was initially allocated to a warehouse.
Absolutely. Exactly.
So, yeah, if you see your job is performing not well or it requires additional resources in some point of time or a week or in some point of some time in a day, we have to manually go and increase our capacity. That is what you meant to say.
Yes, but you don't have to manage it. Snowflake does it for you. All you have to do is and fire the alter command. That's it. And manage, and Snowflake does it for you.
Okay.
Okay, you don't have to go and fill a ServiceNow ticket and then say, okay, we need extra resources. Can you get the approval and so on? There'll be SS admin who will be in charge of this. All you have to tell them that, okay, just make this, resize it or increase the clusters. They will fire an alter command and that's it. You're ready to use it. Behind the scenes, it's the management of procuring or provisioning the EC2 instances. That is the headache of Snowflake and AWS or Azure or GCP.
Okay, after whenever the time is over, for example, Sunday morning to 10, even though if you allocate an additional resources, right, that won't get used. That will be idle. They won't get charged. We won't get charged. Okay, yeah, got it, Abdul. I'm okay. I'm good now.
So even if you have, say, even if this is your existing warehouse, okay, considered with 4 clusters. So if your data load is not using the 3 clusters, you will not be charged for it.
Yeah, I got it. Abdul. It is something like we have to test it, profile it in the production. Okay. So this is a maximum. This is a maximum resource. It is required even if you, for example, if you are running our job which fetches 100 GB of data, but it needs 4 cluster, right? Set the maximum limit and create the warehouse. Just leave it. That's it.
Exactly. Because that 100 GB data, suppose you are expecting on Sunday that, okay, within the 5 or 6 days of week, it will be 70 or 80 maybe or 50 GB only. But Sunday it will be more. So even if you have a maximum configured warehouse, it will not be charged if they are not being used.
Yeah, I got it. I completely understand.
Cool.
Abdul, one question. See, for the month-end load, the same thing. I anticipate that I'll be getting a huge volume of data, but I realized that only after the job started running, and the query went to hung state. In meantime, if I ask the admin team to increase the cluster, and how much time will it take to get it created? Because already my job went to hung state. Will it resume automatically once the clusters have been created by the admin team?
Very good. So Snowflake tells that it takes 1 or 2 minutes to provision the new clusters.
Okay.
And I think that is going to come somewhere in the subsequent slides when we do a deep dive on the virtual warehouses. Okay, so we are going to see how to create a virtual warehouse and how to configure it, what alterations we do, and what is the strategy. So there are kind of modes also in which you have to create your warehouses. So that when you do that deep dive, right? So this point will come into picture, like in what amount of time it takes to provision new clusters and all that. So that time those points will be covered. But to answer your question, it takes minutes. Okay, so I think yesterday we stopped at Snowflake virtual warehouse deep dive, right? This is where we stopped. So guys, any other questions? So I can continue now. Okay, so let me just revisit this slide again. And guys, all these things, right? This is right now theory. So we will be actually creating our Snowflake account. See, it only remains, you get free trial account for 30 days. That's why I'm not getting it created right now for you. Okay. So first now I'm trying to explain you the concepts, and trust me, when you create your accounts, when you start creating your warehouses, databases, all that, you will be able to relate it back with this theory. Okay, so that is the strategy. So it is going to basically, the concept will keep on hammering on you. So that is going to become more solid and solid. Even if it is not solid now, it is going to get solid because this concept is going to keep on getting hammered on your brains. Okay, so yeah, so just don't worry about it. You will ultimately be getting very confident and solid on the foundations of this. Okay, so let me continue now. So Snowflake virtual warehouse deep dive. So compute layer is where all the queries are executed. Okay. Then compute machines need to be provisioned before query execution, which means even if you have configured your warehouse, you say, okay, I need a small warehouse with 2 clusters, still it will not provision you immediately. Okay. It will only provision you when you start the query. Okay. Which is why you won't get paid. And even it will decide, I mean, the service layer, right? Service layer here, it will do the optimizations and it will decide with virtual warehouse layer also that what kind of resources, how much of resources we need to allocate. And even if you have configured your virtual warehouse of say 2 clusters and you come to know, I mean, these management stuff is done by your cloud service layer and virtual warehouse layer itself. So when they decide, okay, we need only 1 cluster for this query execution. So they will provision only 1 cluster, even though you have configured it as 2 clusters. So accordingly, you will be charged also. Okay. But there are certain modes in virtual warehouses where it is mandatory to keep all the clusters on which you have pre-configured. So we will be saying that also. Okay. So it is not that always only those many clusters will be provisioned which are required for the current query execution. It depends on what settings you have done. Okay, so if you have done a particular setting, which you will see later when we do a deep dive on virtual warehouses, you will see that there is particular mode. If you configure that, so no matter what kind of resources your query is requiring, you still have to go and switch on all the clusters for which you will be charged. Okay. Yeah. So then compute machines need to be provisioned before query execution. And these are the services behind the virtual warehouse. AWS is EC2, Azure is Azure Virtual Machines. Then virtual warehouses can be chosen and configured as per the query load. Okay. So which means you can see these different virtual warehouses here, right? So you can create multiple warehouses as per your needs. For data loading, you can create 1 virtual warehouse with 2 cluster small size. For reporting, you can use 4 cluster medium size. So you can have different kind of virtual warehouses, And those virtual warehouses you can assign to the query that you are currently executing. Okay, so say example, this is as I showed you here. Suppose this is your data loading process. So this will be ultimately queries like the insert and merge queries and all that. So if this is a data loading process and you said, okay, I need 4 clusters with small size. So this whole virtual warehouse will be assigned to this particular process. Similar to this, if you have a reporting, say, process for some financial reportings you want to extract, okay, let me say finance reporting. And then for them also, you can have a separate virtual warehouse created. Okay. So here you will have a separate virtual warehouse. Let me just, I will not draw internal nodes and all. Consider that this is a separate virtual warehouse of whatever size you have configured, maybe medium, which will be 4 nodes, and maybe 2-3 clusters, depending upon your research of your query processing. Okay. So that is what it means in this slide. That virtual warehouses can be chosen and configured as per the query load. So guys, as I said just some time back, Snowflake handles the underlying provisioning and configuration of virtual warehouse. You just have to determine the size of the virtual warehouse and create it initially. All the rest, provisioning, when to provision, how many resources, all that will be done by Snowflake. Yes, if you, like we just discussed with Shiva, like if you are still not satisfied with the existing virtual warehouse settings or configurations, you can always do an alter of that virtual warehouse and increase the size or increase the clusters. When you increase the clusters or you decrease the clusters, that is called as scaling up and scaling down. When you increase the size of the cluster, that is you add from say, or even decrease, okay, it's both ways. When you increase or decrease the size of the cluster, which means either from X small, you are increasing it to medium, or you are decreasing it from medium to small, whatever, both ways. That is called as resizing. These two are different. Okay, that is what I was, I think, trying to explain yesterday also. So suppose if this is one cluster, I mean, this is my whole, this whole is my virtual warehouse, and I decide, okay, I want to resize my cluster. So this is right now small, and I want to make it medium. So that means I need to add 2 more machines here or nodes, and this will be obviously applicable to all clusters. Okay. So I have increased. So this is called as resizing. Okay. But if I want to say I want to increase the clusters, so this way I increase 1 more cluster. Okay, I want 1 more cluster here. So that is what it means by scaling up. And tomorrow, after some days, I realize, okay, nowadays data load is less. I don't need this many clusters. I want to remove it. This is called a scaling down. I removed it. And then if I realize, okay, from the clusters, I don't need the medium. I need small only. And I remove these 2 nodes from all clusters. So that will be called resizing. Okay, and these options you will be seeing when we are going to create the virtual warehouses. So that is an important concept to understand, because they ask in certifications. Like what is, they'll tell you that we increased the clusters from 2 to 3. So will it be scaling up or resizing or what? That way they ask. Okay. So virtual warehouses can be scaled up and down at any time. Also, it can be resized at any time. See, they mentioned resize and scale up, which is why these two terms are different. Scale up and resize, right? So even they have mentioned in separate sentences. And it is true, even if your query is running within during the execution itself, you can scale it up and scale it down, and you can resize as well. Then the concurrency management is also done by Snowflake. So when your queries are queuing, right? When they're queuing, so that management of queuing the queries, that is all done by Snowflake. Right. So all this leads to your instant and unlimited scalability. Okay. So the storage scales automatically as data is inserted into tables. Okay. So depending on the pricing model that you have taken, you don't have to go and do anything extra for giving a request for scaling your storage. If your storage is increasing, it will automatically increase, and whatever pricing model you have chosen, as per that, you will be charged. So those pricing model details, we'll be looking into that later on. Then scale compute capacity by adding independent warehouses. Okay, so these are all your independent warehouses, and depending on the workload, you can create your virtual warehouses. For example, this is your storage in between, which is the third layer in your architecture. So see, it has got so many virtual warehouses around it, and each for different purposes. For ETL, for finance guys, for testing and development, analyst, BI, and data scientists, and each of them have different sizes. Okay, this could have 2 clusters, small size. Data scientist might have 6 clusters with large size. Test might have extra small with 3 clusters, so on. Okay, so this is what the issue was in your traditional shared nothing architecture. They were so tightly coupled, and all of them had to be of the same configuration, all these nodes. Okay, because they were a part of single cluster. That is the reason they had to be of the same configuration. But now you can have multiple clusters within each warehouse, right? So that is why it is easier now to scale it up and scale it down and not affecting the storage layer, and vice versa. You can automatically scale the storage and not affect the virtual warehouse. Okay. Then you can scale each warehouse independently to provide additional compute power. So tomorrow, say for the finance users, they are already using 4 clusters, but you want to say, okay, no, I need 6 clusters. What Shiva was saying, what if the data load increases? So I can independently just increase this particular warehouse, scale it up. The power of computation, I can scale it up for only finance users. So as you can see, these are not touched, the other virtual warehouses. Okay, but in traditional data architecture, if there is one node, I mean, if there is a single cluster, if there are 10 nodes, and for one particular node, I wanted to increase the memory, I'll have to do it for all the others as well. Okay, so that is even if they don't need it. So that is a issue. I mean, obviously, as far as cost is concerned, but here this is cost effective. Okay, then automatically scale concurrent workloads in multi-cluster warehouses. Okay, so when you're so basically what we understand from here is also that when there is a concurrency happening, for example, let's consider this and say I have some queries here coming in. Okay, sorry, these are my queues. Okay, my queries are coming here. They are in a, say they are coming in a queue and they are getting they're waiting for their turn. Okay, so say these queries, and say I have only 2 clusters and medium sized. Don't consider these 2. I have configured them like this. So whenever my queries are executing, when they are coming out of this queue, as per the need, the virtual warehouses will be switching on. Okay, for example, if my initial 4 queries are enough for this particular first cluster to be processed, it will just switch on this cluster, this first one only. It will not switch on the second cluster. Okay, and say 2 more queries, say suppose they are waiting in the queue. Okay, so there are certain modes, as I told you, that we have to configure when you are creating a virtual warehouse. So depending on that, it might wait for this particular cluster to finish its processing for some time, because unnecessarily you don't want to spin up the other cluster. Or if you have a particular mode chosen, it can immediately spin up the other cluster and not waste time for the queued queries. So it depends the kind of mode that you are selecting, which will be seeing in detail also. Okay, but for your understanding, this is called as concurrency, right? When you have so many different users hitting on the virtual, I mean, your storage area and virtual warehouses to do their respective queries. So this management of concurrency, that will be handled by Snowflake itself. You don't have to worry about it. It will automatically manage the virtual warehouses, spin it up, spin it down. They will do it automatically. And normally for concurrency issues, we scale up. when we know that there will be a lot of concurrency happening, that is the time we scale up. Means we add clusters. And the time when we know, okay, particular queries will take time to execute or process, that is the time when we do resizing. Okay, so that can also come sometimes in the certification, that there's a query processing which is taking a lot of time. So will you add more clusters or will you do resizing? Okay, so these two you should remember. For concurrency workload, we normally do scale up and scale down. And for query processing, enhancement of performance of a particular query, we do resizing. Okay, so here, that is what it is trying to tell you, that you can have independent. So this virtual warehouse, in the bottom line is virtual warehouses and your storage layer are, decoupled completely, independent of each other. The pricing is also independent, and the scalability, whether it is up or down, is also independent. They don't affect each other in any way. Okay, so let's come to a query lifecycle, like what happens when you submit your query to the Snowflake. Okay, as we know, Snowflake is made of 3 layers. The bottommost layer is your data storage, then your virtual warehouses, and then your cloud services. Okay, and then you can have external connectors to it. Maybe if you want to connect it to any BI tools or visualization tools or some programming language, Python, Java, like that. Okay, that is also possible in Snowflake. So let's look at what a query lifecycle looks like. Okay, so on query submission, we must specify the kind of virtual warehouse we need for processing it. Okay, always remember, and even when you create your account and when you run queries, you will be noticing, for example, this query, suppose this query comes here. Okay, this query comes for execution. It has to know which virtual warehouse is going to do my processing, whether this virtual warehouse is allocated to me or whether this virtual warehouse is allocated to me. So without that, your query will not run. Okay, so that is the first step, that you should make the query aware that which warehouse it's going to use. Then the cloud service layer creates the user session and authenticates if it's a valid Snowflake account and its desired privileges on the object it's trying to access. It's simple. So the cloud layer, when you are logged in, it will authenticate your passwords and all that. It will create your session. So whenever you connect to your databases, currently if you're working on Oracle, MySQL Server, or MySQL, or any database, always when you switch on the database, it basically creates a session for you, right? So that is what Snowflake will do. It will authorize and authenticate its required password authentications. And also, if suppose you have submitted a query and you want to access customer database, it will also go and check whether you have the necessary privileges on the customer database. For example, you say, I want to find customer names from the customer table. Select customer name from customer table, like that, suppose. So it will authenticate whether you as a user, which you have logged in, suppose, okay, Shiva has logged in with his username. So does that particular user has access to that table? Okay, so that it will determine. So it is nothing, these types of things are called privileges, right? So that is what that will determine. Then the query parsing is done. Okay, then it will not immediately go and provision the virtual warehouses, because we all know that by now that query processing is done by the virtual warehouses. Okay, it will not immediately go and spin up your virtual warehouse that you have allocated in the beginning. It will first see whether this query which you have submitted, does the result of that query is lying somewhere in the cache. Okay, so cache is a very big topic and separate topic that we are going to cover, because there are 3 caches available in Snowflake at each layer: cloud service, virtual warehouse, database. There are caches available, so we need to understand them also in detail. But as of now, we are seeing what a query lifecycle is. So it will not immediately spin up any virtual warehouse. It will first go and see, does this result of this query available in the cache? And also it will see, has that particular table undergone any changes in the recent past? Like, has there been an update, or has there been a delete or insert? Okay, so that it will check whether the underlying data has changed. So as you know that metadata management is available with cloud services. So with the help of that, it will find that out. And if nothing has changed, it will give it to you immediately on the screen from the cache. In that case, your virtual warehouses will not be spinned up and they will not be used. And this is also not costed. Okay, you are not charged anything for this when the data comes from cache. So that is a kind of big advantage, right? So mostly your dimension tables or your master reference data tables, they don't change, right? Most of the time. So if you keep firing them on in the cache and they keep coming in the cache, so you will not be charged for virtual warehouses because the result is coming from the cache itself. And also there is a particular time frame for that result to be kept in cache. Okay, I think it is 24 hours. Within 24 hours, that cache gets cleaned up. But within 24 hours, if you are firing that query 100 times, you will not be charged. Okay. Then the optimized query. So now you know that, okay, I don't have cache to look up. I will have to spin up the virtual warehouses. Then a plan will be generated for the query. Okay, and this in our traditional databases like Oracle, we generate explain plan, right? We see what is the cost and what kind of resources are being pulled, how many rows, this, that. That is automatically generated in Snowflake. Okay, you don't have to go and explicitly do that. That plan is generated by the cloud services layer and it is sent to the compute layer, which is nothing but your virtual warehouse. Okay, then depending on that, virtual cloud services layer resumes the virtual warehouse if it is in suspended mode. Okay, or spins up a new one if needed. So, for example, if the virtual warehouse is suspended, I mean, what happens is once your query, say these are your virtual warehouses, right? So when your query is running and when it is finished, automatically your virtual warehouse is switched off by the Snowflake. Okay, because the time it will be on, you will be charged for that, right? So automatically Snowflake switches it off. So that is called a suspended mode, basically. So if it is in suspended mode, the cloud layer will automatically spin it up. Or if it is already in the progress, if it is already doing some query processing, and you have multiple clusters associated with that virtual warehouse, and if it is required that, okay, I need to switch on the other cluster, it will switch on the other cluster. So depends on what is the condition scenario that time. And last is quite simple. Virtual warehouse executes the query and returns the result to the user. This is all when you're not getting the result from cache. Okay, if you're getting from cache, all these steps are skipped. Okay, so and all this is automatic, which is why there's minimal management. Okay, if you see in your Oracle, you have to explicitly mention in your functions and procedures that you have to configure, say that cache should be on, enable cache. Some kind of a syntax is there in functions and procedures. Here, there's nothing like that. You just need, Snowflake does it automatically, all that for you. So which is why this management and all that is very minimal. Okay, so this is
this Venkat, I have a doubt too.
Yeah.
See, for example, if I run a query by 12 o'clock, I have an employee record of 1,000. So the first will be in the database and the virtual warehouse. Okay. After
repeat that. Sorry, repeat that.
Okay.
What did you say?
Maybe just like give you a scenario just for my understanding.
Yeah.
So first there is an employee table that has 1,000 records. So initially that will be in the data storage and the cache, the virtual warehouse. Okay.
No. Initially it will not be in cache. If it is the first time, you are querying, okay. If it's suppose you are first time querying your employee, select star from employee, okay. That is the first time. So obviously cloud service layer will not find it in the cache.
Okay. Okay. So, okay. First time I'm selecting out, maybe that will go to the from table. Maybe second time it will go in the, it will be in the cache, right?
Yes.
Okay.
Yes.
And then between the, say after the second time, I'm inserting one record in the database table. Okay.
Yes.
So now the record begin employer 1001. So when I put a select now, it will take from the cache or it will go and check in the main table because the record has increased.
From the main table.
How it will differentiate whether I need to take from cache or maybe the metadata table data
Yes.
difference based on that.
So this cloud service layer, right? Yeah. So this cloud service layer here, it is responsible for the transactional consistency. Okay. So this is what your consistency is, right? Where if I updated some table or inserted some table, the exact state or the current state of that table should be available across. So that in traditional architectures, in the shared nothing, earlier the data was specific to each node, right? So if suppose in first node, I inserted in employees that table, which you are asking about. So that consistency has to be communicated to all the other nodes also. Okay, if it's wanting to access employees table, but here that metadata is maintained by the Snowflake layer here, the cloud service layer. So that transaction consistency is maintained here. Okay, so it will know that, okay, something has changed, that cache is useless for me. I need to go anywhere to the storage and bring up the data. That is how it decides.
Okay, the metadata decide whether I need to go to the cache or the centralized data storage.
Yes, because what happens is when you read about, I mean, when we come to the micro partitioning part, okay, like how our storage data here, how it is behind the scenes actually stored in the S3 bucket, in what form, what is the data structure of your tables, okay, data that you're storing here, that time you will see how it does. So basically, it is, to answer your question, it is the metadata through which it will find out.
Okay.
And that is all automatic. You don't have to do anything.
Yeah, Abdullah, what I believe, right, based on the resemblance of Exadata architecture here in Snowflake, right, it is the change what to decide. For example, inserting in a new record, right, the architecture, how the Exadata works is, the architecture, how they designed is, if you insert a new record, it won't go and search existing whole table, right? If it is only an additional record, it will go and fetch the additional records and put it in the cache. That is how the other databases work. Maybe in Snowflake also, it should work like that. For example, I have 100 records. I ran the query. All the 100 records are put it in the cache, right? Then 9 o'clock, I ran the query 8 o'clock. 9 o'clock, I inserted another record, which is 101th record, right? If I run the query, all 100 records, since it has only inserted another record, it should not, what I believe based on the architecture, I believe it should not go and fetch all the 100 records again. It should go only fetch the 101th record and add it in the cache. That is how the Oracle Exadata architecture works in the caching environment, right? So maybe Snowflake also may work like that.
Okay, so there is a caching topic in detail, okay, which we'll be studying, because that is all that caching topic itself will take 2 hours to complete. So since this is a query lifecycle, so we have to mention what are the steps here, right? So caching check is there in between. So that is why I have to tell you that, because, but when we are going to see that caching in detail, there are different caches available, as I said, in cloud service layer, virtual warehouse layer. So that time you will get to know about all this. Okay. So that time we can also, but as far as I know, it will not take from the cache, even if it is one record that is inserted. go and fetch everything from your warehouse or sorry, storage. Okay, because I'm not aware how
yeah, I got it. So because not required to be same, right? It may be a different architecture and strategies. Snowflake could use it, right?
Right.
We will deep dive more into cache later.
Right, but what we will do is we can do this experiment also. We can anyway when we are going to do the caching topic, that time we'll be firing query and see, okay, first time see virtual warehouse is being used. But second time that same virtual warehouse will not even be started because already the result is in cache, so you don't have to use virtual warehouse. So all those scenarios we'll be seeing. So in that case, what we'll do that time, we'll insert one extra record and then we'll see what happens. Okay. Because what I understand your point that why do you want to go and refetch all the 1,000 records? Why not take the 1,000 records from the cache and take one extra from the storage? That's what you're trying to say, right?
In this case, right, Abdul, insertion, it will not result in any consistency problem, right?
Right.
It is just adding a record. If you say, if I delete this 15 records in the hundreds records, so we're keeping a track of what are the records it is deleted and okay, remove those records. That is, it may result in a consistency problem. But adding just a new record should not result in a consistency problem. Even I see this architecture in many of the new databases. Maybe in Snowflake, maybe it may work as you said. We will see.
Okay, yeah, we will see. But as of now, I have not come across this particular statement in Snowflake that in such cases it will take whatever is there in cache and then bring the rest of the data inserted from storage. I have not seen that statement. But yeah, your good point. Let me have a look at that. If maybe I have missed it somewhere in the documentation, but as far as I know till now, I have not seen any such special condition for insertion case actually. Okay, guys. So moving forward,
Abdul, last note regarding cache. See, actually, for example, I have two different tables from two different databases. For example, the employee table will be my primary table, and we have the finance table. Okay, now how do it cache it will reside actually? Whether I want to go to the first one or second one, how it will reside, how it will take.
Okay, so as I said, cache is a different topic, guys. We are definitely going to look at it, in detail. Okay.
Okay.
Let me just show you the course syllabus also. Okay, let's show you. See, caching in Snowflake, right? So we'll be looking at the types of caches, caching demo with examples and live exercises, right? So this is a big topic. I can understand, the excitement or maybe the curiosity basically around it. But this is a very big topic in itself. So we will definitely cover all that. But to answer your question, if it is say select some columns from employee comma DPT, where employee department equal to department, that's what you're trying to say, right? If you join the tables.
Yes.
Right. So it does not store individual tables. It stores the result of that query in the cache. Okay. So when you fire the query, fire that query again, so it will check whether those underlying tables have changed, whether the employee table has changed or whether the department table has changed. So obviously, if they have changed, then your cache will not be the correct reflection of that query when you submit it the second time. So it first determines whether the underlying table has changed or not. So it is not storing when you're firing a SQL query with join conditions. It is not storing individual tables. It is storing the result of that particular whole query in the cache. Then it already has the metadata of each table with it, right? It will have the metadata of employee. In the metadata, what all it will have? The number of records, the counts, the distinct values, and all that detail we'll see when we come to micro partitioning. So that time it will check in the metadata of each table because cloud service layer has the metadata, right, for each layer. So that time it will see, okay, the underlying tables, have they changed? Is there any change in the metadata as compared to earlier? If there is, it will resubmit, it will re-execute that query with the join conditions. But if there is no change in the metadata, either of the tables, it will directly pick that particular result of the query which was there last time. That is how it works.
Okay. But my question was different. Maybe I'll ask during the catchy session. That's okay.
Okay. Sorry, I think I did not understand. But okay, you just park that question, and when we come to caching, just remind me of that. Okay.
Oh, sure.
So yeah, this is a diagrammatic representation, guys. So these are the steps, how it works. So here you can see this is the first step here, where your SQL query is coming into Snowflake, and it can come from any of the standard ODC, ODBC, JDBC, or web UI interface. So we will be working on web UI interface of Snowflake. So like how you have a web UI for Amazon, right, AWS. Similarly, you have a Snowflake web UI. Okay, so let me show you that as well, like how the web UI looks. Don't make any account, guys, because it will expire in 30 days. And this is a weekend batch, right? So, it might be a little problematic for you. But anyway, keep 2 email IDs ready. So all you need is an email ID. Through that, you can go and create your trial Snowflake account. So this is the web UI, guys, of Snowflake, which I am logging into. So this is where we will be working also. I'm just showing you the console, how it looks. Okay. So this is my Snowflake web UI. This is how it looks. And I will be giving you a detailed tour of each tab. Okay. See, you have this warehouses here. This is where you create the warehouses. So see, I told you whether it is in suspended state or resumed state. So that all I will be showing it to you. And when I show this to you, and when you will relate it back to theory, you will get a more solid understanding. In case you have doubts now, you will get more solid understanding. So this is how a web UI looks, and here is where these worksheets you will be finding queries and all. So this all details I'll be showing you. And anyway, you keep 2 Gmail IDs ready, guys, because I don't think 30 days, within 30 days we can finish course because we are weekend batch, right? So anyway, keep 2 email IDs ready. Cool. So second step is result cache lookup. And third step is your planner query, where planning and optimization of the query. Okay. Then your fourth step here is the virtual warehouse layer, where virtual warehouse will process your query. And ultimately, the fifth step is it will process the data and return it back. And it will also store it in cache for future use. Okay. So whatever query, whether it is a joining of 3-4 tables, it's a single table query, whatever it is, the result will be processed. It will be stored in cache for future use, and it will be returned to the client also. So client is nothing but, go back to number 1 here. The place from where you submitted the query will be your client, basically. So there it will be returned. Those results will be returned to you. Okay. So this is an overall query life cycle. This is how it looks. Okay, guys. So I think we have done a good enough deep dive of architecture, right? So let me just revisit back. Okay, so let me pick up someone. Okay, so Vinod, can you tell me how many layers are there in the architecture of Snowflake?
Yeah, there are 3 layers. First is the storage layer. The second layer is called the compute layer, and the topmost layer is called the services, where we will have all the connectivities from which way we can get the data from the storage.
You don't get data from cloud services. You get data from virtual warehouse. Okay?
Yeah, virtual.
So your cloud services is basically responsible for the management.
Okay.
Okay. That entire life query of this we saw, right? Query life cycle. This whole management is done by one cloud service layer, but the actual processing that, okay, I need to fetch so many records, I need to do the joins, and I need to do send back the result. That all is done by your virtual warehouse.
Yeah, got it.
Okay.
Yeah, got it.
Fine. Thank you, Vinod. Okay. So Sudhakar, have you joined today?
No, Abdullah, I joined yesterday only.
Oh, you joined yesterday. Okay. So Sudhakar, question for you.
Yeah.
On what all clouds providers can we host Snowflake?
Sorry, Abdullah. Actually, I would have missed that one. I'll go through your video once again.
No worries. So currently Snowflake support is given on AWS, Azure, and GCP. Okay. This is just for your information. No other cloud provider supports Snowflake right now, only these three. Okay.
Okay. Thank you.
No problem. Then, okay. Venkat, can you tell me what is resizing?
Yesterday, I wrote attended. Yesterday, you told about resizing, huh?
Yeah. Yesterday, I told about resizing, and sometime back also, I just like explained the difference between scale up and resizing. Actually,
first 10 minutes also, I am not joined. Actually, I joined after that PPT.
Okay. I'm sorry about that. I did not realize you joined a bit late. Sorry. Okay, so let me ask that to Shiva. Shiva, can you please tell me what is resizing and explain to Venkat also?
Yeah. There are two issues, right? Concurrent issues and the performance issues. When we have the concurrent issues, right? So we do scale up or scale down, right? For example, we have 4 or 5 users submitting a query. So first query is being executed. The other 3 are waiting in the queue. So where we have a concurrent issue, which we have, so in this case, what we will do is we will scale up or scale down. Scale up. Scale up means adding entirely new clusters, right? That is called I think scale up or scale down. The resizing means when your query is taking long time, you face some performance issue where you think you need some additional nodes in existing clusters, that is called resizing. Right? For example, you have 3 nodes clusters, right? If you feel that
we don't have 3 nodes clusters. It's always factor of 2.
Yeah, 2 or 4 or whatever multiple stuff to, right?
Yeah.
If you decided that I have to make it additional 2 more nodes in the existing cluster, maybe that is called resizing.
Exactly. Yes. So Venkat, I hope you understood. Whenever we add extra nodes within the same cluster, that is called as resizing. And when we add extra clusters, not extra nodes, okay, extra clusters, that is what we call as scale up.
Okay.
And similarly scale down, like if you decrease the clusters or decrease the nodes, that will be scaled down, and so resize only. I mean, resize means it could be up or down, both.
Okay.
So this is where your warehouses reside, guys. So these are all I have created. Okay, so sorry. Okay. So if you see, I told you, right, you can choose the size you want. So this is the sizes which warehouse comes with. So if I choose X small, that is one node basically. Here, basically behind the scenes, EC2 is being provisioned. But as you can see, I don't have to worry about how it provisions EC2, what EC2 configuration. I don't have to worry anything about it. All I have to say is I want this size. I want one computer, I want two computers, I want four computers. That's all I have to say. This is your resizing here. And then if you say, okay, this, and you can see it says, learn more about virtual warehouse sizes. So basically this will lead you to the documentation. Okay. Then here is where your clusters you define. Okay. How many clusters I want? So maximum up to 10 currently Snowflake is providing. Okay. And this is 6x. The size is 6x currently which Snowflake is providing. 6x means this 512 nodes in one cluster. Okay, imagine 512 nodes in one cluster. So if anybody is here from big data and knows about HDFS, imagine the kind of scalability issues you will have when you want to get so many, computers. Okay. Okay. So where is last? So this is my last question, I think. So Anubhav, one last question for you. Okay. So say if I go with small cluster, okay, with small size, not cluster, sorry, with small size, okay, and maximum clusters, I want say 8. So what will be the total number of nodes that I have for my warehouse? So can you hear me, Arun?
Yeah, I can hear you.
Yeah. Did you understand my question?
You have selected small size. So I'll
Yeah.
have only 2 nodes and 8
Yes.
clusters, right?
Right. So what is the total number of nodes I have?
So per cluster, I'll have a 2 node. So
Yes.
16 node I'll have.
Exactly. Exactly. Okay. Cool. Yes. Okay. So now let's come. So this architecture here is completed. So guys, which one is, so, okay, this question is also asked. It's a simple question only. I'll ask it to Chidambaram. So Chidambaram, what is known as the brain of the Snowflake?
Compute.
Okay, so Vinod is raising hand. Vinod, go ahead.
Services.
Correct. So Chidambaram, services layer is the brain of Snowflake, okay? And
compute is a muscle, right?
Yes, muscle. Compute is the muscle, and brain is your cloud service.
Storage is the muscle, right?
Who is that? Sudhakar?
Yeah.
No. Storage is not the muscle. Muscle is virtual warehouse. Because it is doing all the heavy work, right? So, I mean, all your heavy work is done by the bodybuilders, right? So that is the muscle work. And all this query processing and all this management is being done by your cloud services layer, right? So it is doing the intelligent work here. It is checking the metadata. It is doing the transaction consistency. It is creating user management sessions. It is authenticating stuff. So it's doing all the intelligent stuff here. So it is basically called as the brain. Okay.
Okay.
Fine. So let's move forward. So guys, Snowflake basically comes in different editions. Okay. There are 4 editions which Snowflake comes in. The basic one is called as standard edition. Then after that is enterprise edition, business critical edition, and then virtual private Snowflake. So most of the clients or business that I have seen goes for business critical editions. Okay. And each edition inherits the features of the previous edition. For example, if I go for enterprise edition, I will be able to inherit all the features of standard edition. Okay, so this holds. So if I go for business critical, I'll be inheriting all in enterprise and standard edition features. That's how it works. Okay, so if I show you from their website, okay, you can just go to snowflake.com. Here it is. See, snowflake.com here. Or you can just say Google and type Snowflake editions. So see, you have four different editions here. And the basic is your standard, enterprise, business critical, virtual private Snowflake. Okay, so in this, all these, there's quite a few features here. Obviously, it is not possible to remember everything here, and it is not expected for you also to understand everything, within each edition. The only thing that there's certain important stuff that we need to know, and that we will see. Okay, so looking at your standard edition here first. Okay. Yeah. So this is the same diagram. I have taken it basically from the website only. Okay, I have used my snipping tool and I have taken it from here. Okay, so let's look at what standard is and what it does. So it is basically a complete SQL data warehouse. Okay, which means simply you can write all your SQL queries and native SQL queries here, ANSI supported SQL queries, and also Snowflake specific SQL queries. Okay, so for example, Oracle has its own SQL queries functions available with it, right? Apart from the ANSI standard. So those will not work in SQL Server, right? Which is specific to Oracle. So similarly, Snowflake has its own. So that all you can fire in standard edition. And if I just showed you the web UI, right, which is my user here. Okay, so if I click here, it will show me my edition on which I have created, and it will show me also the cloud that I'm hosting my my account of Snowflake in, and what region I have chosen. So when you're creating your account, right, that time it will show you all this. That time you will have to select all this. What edition I want, which cloud provider I want, and which region I want to host it in. Okay. So as you can see, I have created business critical and I have chosen AWS. So there it will give you three options, AWS, Azure, and GCP, because right now only these three are supporting Snowflake.
Abdul, I have a question here, right?
Yeah.
When you say region, I got to know how this data replication and backup recovery steps, those things and all are managed by Snowflake, Abdul.
There are zero copy cloning and data transfer and all that stuff there. So zero copy cloning, when we study, that time you will get to know how we can replicate data. Okay, because cloning is nothing but replicating, right?
Yeah.
So where is my, just let me open the course just a minute.
Yeah, because in AWS, they default have data replication, right?
Yeah, that is your availability zones you're talking about,
yeah,
right?
Yeah. In the region, we can choose data copy in different region also, different availability zones, zone also.
Yes,
how
yes.
this Snowflake is leveraging that. So we have separate concept for that.
Yes, yes. So there is something called as fail-safe in Snowflake. Okay, that it does. Then there is zero copy cloning also, which you can replicate basically. You can recreate that existing database. I'm not seeing it here, but it is part of the course.
Oh, okay.
Okay, where is it? Okay, I'm not sure why is it not there, but yes, zero copy cloning is there in the topics that we're going to cover. And also yeah,
you can complete up.
Yeah, so to add on to what Shiva asked, you have various ways basically. So there is something called as time travel also. You see here, this time travel, that is also available there. You can go into the past and see the state of the data. Then you have fail-safe mechanism also, where you will have your data replicated, or maybe it will store somewhere in the availability zone. That is not your concern basically, because all this management is done by Snowflake. You don't have to worry how it does. You just have to know, okay, there is a fail-safe concept. Okay, what fail-safe will do. Okay, so that you have to know. And apart from that, there is something called as data replication also, which is your zero copy cloning. So if you worked on these traditional databases, on-premises databases, right? Each time there is a release, we do a production recreation in the UAT environment, right, guys? Shiva, you might have come across this, right?
Yeah.
For your UAT testing, each release, maybe quarterly or how your release strategy is depending on the client. Always you replicate your production into UAT or pre-prod environment to do the testing on that.
Yeah. We have a different, we call it as ice type environment. We have around 20 to 25 ice type environment for the production environment, right?
Right. So you will replicate it for production, right?
Yeah, we have a complete data set of a weekly data set or monthly data set for the production data.
Right. And how much time it takes?
To replicate the entire data?
Yeah.
It takes around 4 or 5 hours.
4 or 5 hours.
It runs on Exadata, Oracle Exadata as of now.
Okay.
So we have around even test environments itself, we have 20-25 environments, which is
right.
Based on the geographical region. We have production itself, we have 15 to 20 production environment.
Correct. So the replication is basically you have to export your all your
it is conventional data copy.
Right, conventional copy, right? You have to export your data, export a schema, and then put it on the other database, all that conventional way. But here, but here in Snowflake, when you do this zero copy cloning, right, it is instant, and we'll know how it does that. So which is why all those bottlenecks and overheads are being reduced now with this advent of cloud data warehouses coming into picture. Okay, which is why all those management stuff and your time around, that is decreasing to a great extent, actually. So, yeah.
Yeah, that's why every organization is exploring adopting other cloud, those technologies, right? So many are decided to go, what is that? Redshift.
So, Redshift, Amazon Redshift, yes.
Yeah, Redshift. So my company, they are trying both.
Okay.
They are trying both. They'll decide whichever is economical and efficient for them.
Absolutely.
Redshift is way cheaper than Snowflake. As of now, what they are discussing is.
Okay.
Yeah, but we'll see what they decide. But they definitely they have to, every enterprises have to adopt a new cloud technologies.
Yes.
Maybe another 10 years, right? Having a database running in on-premise data centers will be very less.
Correct. Yeah. What a floppy disk is to today's generation, that will be like on-premise for in the coming 10 years. Okay. No, nobody will know if that existed also. That generation basically. So yeah. Yes. Yeah.
Many are due to the existing contract obligation. For example, right, for our client, right?
Yeah.
We are a platform, SaaS platform. We can say services, software service.
Software, yeah.
So where we are maintaining the data for around 150 banks, 150-200 banks across the globe, all wealth platform, investment banking data. Oh, so as per the existing contractual obligation, they may not go to the cloud.
Right.
So company is only permitted to store their data in only one location. So there are a lot of contractual obligations that they cannot go to cloud so easily. So now when there are new contracts being signed between our company and their client, they are also including a class of possibility of having data in cloud.
Right.
So these are all the factors, reasons that many of the companies are still not going to cloud completely. But every company in US, I'm in the eastern region of US, at least every company, as of my knowledge, every companies have started initiatives to move to cloud.
Yeah, even as I said about the project that I was working a month back, even they are, so it is an on-premise Oracle database we work on. So they are now moving it on the Google platform, GCP. So it's a 1-year plan. It's not going to instantly happen, but yes, they have started the process.
Yeah, they already whatever in my company, whatever the technology they are telling, right? They are trying it and doing some POCs and test cases, and they are dropping. It won't work for us. Like that, they are one by one they are doing. Even cloud also, even the big data also tried, Spark and all they tried. They did not work it well. Even they cannot stand in front of their requirement what we have, the massive data and all. So they dropped the plan. So they are maintaining still in Exadata platform.
See, what is good about Snowflake, right? You just mentioned Spark. That is why I'm trying to say, just going a little off topic. Okay, guys. So see, Spark is what your virtual warehouse layer is here. Okay, it is just as processing. I mean, not just is not the right word, but Spark is a great data processing tool. Okay, it is quite fast and it is very, I mean, good for processing the big data. So, but Snowflake, with Snowflake coming with its own computing power, I mean, Snowflake doesn't have to go or connect to some external computing resource. Okay, I am just a storage related technology. I need help for computing. Please help me. Spark, basically, when Hadoop came, so HDFS was basically being the HDFS file system, which is the storage area of Hadoop. That was getting processed by MapReduce part. So MapReduce was the processing layer there, right? But MapReduce was way too slow. So they came up with this external technology called Spark, which basically replaced MapReduce and then started to work on the storage layer. So here that issue is not there. That my storage area here, it doesn't have to go to Spark. Okay, please process my data. It has its own computing power here. It can scale it up, scale it down whenever it wants. So, which is why the Spark popularity or all that big ecosystem which had come with big data also, right? These various tools, Scoop, Hive, this, that, Spark. So even it is kind of becoming a one-stop shop, Snowflake. So yeah, I mean, I heard Spark. That's why I just thought of bringing this topic.
Yeah, what I see a big benefit of Snowflake is right, the adaptability, right? When some companies using especially Oracle Exadata warehouse infrastructures, right?
Yeah.
Adapting to Snowflake is not quite difficult. It is quite easy because all the terms that you are referring, right? As a person who worked in the Exadata environment, everybody will easily understand.
Yes.
Right? Maybe they tweaked, as you said, they have benefited by picking up the most successful terminology or architecture and built a Snowflake. But whatever any terms that we are referring in the Snowflake, it is not new.
It is not new, but there are certain concepts which are new, like time travel, fail safe.
Yeah, for example, in our concern, right, there are, if you see, there are 300 to 400 Oracle developers are working across the globe, right? So when they go to Snowflake, it is easy for them to adopt the new technology.
Yeah, absolutely. So that's what the learning curve for SQL, PL SQL, the Oracle guys, or any database guys, the learning curve for Snowflake is very fast. Within 30 days, you will be a Snowflake user. Okay.
So for this hiring 200 new resources, right? It will take at least 3-4 years to get the business platform knowledge. In our client, right, the knowledge is the key. Anyone can write the PL SQL code, but the knowledge, the wealth platform and investment platform knowledge is the key. That is why they don't leave a resource easily.
Right.
So,
correct.
Yeah, the adaptability is very easy. That is why they are trying.
So this is a very logical progression for anybody's career who is into databases. Snowflake is a very good logical progression to have in your resumes. Okay. Sorry, somebody else was also wanted to asking a question. He told me to complete my stuff.
This is Venkat Abdul.
Yes.
See, actually, I can see in a demo login, we can able to access the business critical also. But normally, if we get the SQL demo login, normally we'll have the standard access only. So if we get the business critical, can I get all the options in that demo login of the business critical?
You mean the features which SQL, this business enterprise or business critical provides, all this?
Yes.
Yes, you can.
Then
for free,
every 1 month,
for free, 30 days.
Every 1 month I can change and I can create one account and use for free.
Yes. Definitely. You need to have those many email IDs. But
we don't need a credit card, Abdul, because for AWS account, you need a credit card.
Yes, for AWS and any other cloud, when you log in, create your account, that time you have to put your card details.
Yes.
Here you don't have to.
Yeah, we cannot have so many number of credit card, right?
Yes, you don't have to do it here. Because, okay, let me, because, sorry, what am I doing? You cannot do. Let me show you something just to kill your curiosity. When we are going to create our account, okay, we are going to type Snowflake login, and this is the first link that we will get. We will click there.
I could not able to see your mission, Abdul. Others can be able to see. I can see only the name section.
No, okay.
You can see only the name section.
I'm sorry. Now can you see?
Yes, Abdul.
Okay. Sorry, I think by accidentally I switched off the recording. No, not recording, sorry, the share. Okay, recording is going on, fine. Okay, so guys, when we do this, so every one of you, right, when you will be creating the Snowflake account. So as I just showed you, we will go to Google, okay? We'll go to Google and we'll just type in Snowflake login. And this first snowflake.com link which will appear, right? We just click there. Okay, so you will come across this page, and here there's something called Start Free button. You'll just go click this. Guys, don't create it yet, okay? I'm just showing it to you because I mean, every one of you is curious, right? Just want to show you how it looks like. So it will say start your 30-day free trial, okay? So this will be 30 days free for you, everything. And you have to fill, and you will also get $400 worth of free usage when you test drive Snowflake. So you can use storage, compute resources worth $400. So which is, you don't have to pay, I mean, anything up to $400 within a period of 30 days. Okay. And which is why you don't have to fill your credit card details also. See, here it is not asking anything. All you have to do is just, fill your details here. That's it. I'll show you how it looks. Then you can just write any company, whatever it is. Then your region, you can choose your region. Okay, then continue. See, it will ask you the different additions which you want to have. Okay, and every feature that is promised by Snowflake, depending on its addition, is given to you also. It is not that, okay, it is free and for demo purpose, so we will not give you this. It is not like that. You can use any of these features that are provided there. And so there are 4 editions, as I told you, right? Standard, enterprise, business critical, and virtual private also. That is not available here when you are doing it for free. And I have never used it also. So I am not much aware of that also. And then there are 3 cloud providers, as I said, it will choose from. You have to choose from. And then
I
you
think
can get
for virtual private Snowflake, right?
Yeah.
They will use AWS VPC, the virtual private cloud, the separate logical infrastructures, right, for their cloud.
Yes.
I feel both are same.
Yes. So this will have a virtual, basically a dedicated data center for your business. Okay. Here, whatever EC2 machines you get from Snowflake is from the pool of EC2 machines. Okay. It's not a dedicated server given to you. But in virtual private Snowflake, I think those machines are dedicated for your business. Okay. So this is how your web UI you will be creating. So when you create this account, like how I have logged in to my account, right? That is how you will also be able to log in and see all this stuff here. So I will explain you all this in great detail. Okay. Fine. So let's come to the additions. So see, most of the things I also don't know, like what kind of support these additions give. Because as a developer, we are never bothered about all this. I mean, these are all taken care by the senior architects and senior management guys. I mean, we as developers are only concerned about the concepts that we use on a day-to-day basis. So, so I'll just run through what all these features are provided. So as I said, there are 4 editions in which Snowflake you can get: standard, enterprise, and business critical and virtual private Snowflake. And each edition you can inherit the features of its previous counterpart. So standard features. So as you can see, this enterprise will have standard plus features. This will have enterprise plus and business critical plus. So obviously, if it is enterprise plus, it means standard plus also. Okay. So let's see what kind of features each edition provides. I mean, some of them I also don't know. So complete SQL data warehouse, you can fire your SQL queries. I just showed you how you can do that in the web UI. Then it is a secure data sharing across regions and across clouds, guys. So what is the edge of Snowflake over Amazon Redshift or even the other cloud databases? It is not easy to do cloud data sharing, even inter-cloud data sharing from AWS to Azure or Azure to GCP. It's not easy. You can do it. I'm not saying you cannot do it. Anything is possible in technology, but this is secure and very, very easy also. I mean, easily you can do it. Okay, so you can basically do data sharing across regions. For example, I think Shiva only had asked last time that I am in UK and my boss is somewhere else in US. So how to do data sharing? So there is something called as data sharing, which you can do across regions. So this incurs cost also. Okay, so when we are into pricing, I will show you the cost list. Okay, then there is a premier support. So there is no bias if you use a basic standard edition. Okay, they give you support. You can always go and take help here. This chat here, right? You can always go ask them your issues. Also, you can mail them to their supporting for your issues. Okay. Then it is having a 1 day of time travel. So basically, time travel we are going to study in detail, guys. So time travel is nothing but you can go back in time and see what was the data during that current timestamp. I mean, that particular timestamp. Okay, so this is handy when you want to compare stuff. Say, for example, there is a sales data that is, you're incoming into your data warehouse. Today, there are some sales, and you want to go and compare it with the sales of yesterday. So you can go back to yesterday's time and see back in the past. Okay, so and compare it with yesterday's sales and today's sales. But in standard, only up to 1 day of time travel you can do. Okay, so you can go back in time for only 1 day. That is the limitation. And if you see here, compared to that, the enterprise detail edition, it says up to 90 days. So you can go back up to 90 days of time travel in enterprise edition. And how to do that, how to do it through the SQL queries, there's a separate topic of time travel, which we will see. Okay, so always on enterprise grade encryption in transit and rest. So which means when you are loading data from somewhere, so that is called your transit, right? So it is that time also there is encryption, and when it is at rest, basically when it has come and settled in your storage area, so it is resting there, right? So that is also your encrypted. Okay, so both the times, whether it is traveling from somewhere outside into you, that time also it will encrypt it for you, and when it comes at rest, that time also it will encrypt for you. Then, as you can see, it says customer dedicated virtual warehouses. Okay, which means you can create your customer dedicated virtual warehouses, but you cannot have multi-cluster. If you see in the enterprise, it says multi-cluster warehouse. So in certifications, guys, they ask you up to, okay, which edition provides you up to 90 days time travel? Which is the minimum edition which provides you up to minimum 90 days travel. Okay, so you have to select enterprise. And it will also ask you true or false. Does standard support multi-cluster warehouse? So you have to say false. Okay, multi-cluster means this is my multi-cluster, right? This is my one cluster, C1, C2, C3, C4. This is not possible if you choose standard. Okay, it only one cluster you will get in standard. So please, for experimenting, don't create a standard one, because otherwise you will not be able to change the addition later. We cannot change the addition later. Okay, so yeah. Federated authentication, I don't know what it is. Database replication also is zero copy cloning, which we will see. Then external functions, which is your AWS Lambda functions, also you can call from your Snowflake. And the other thing which it says, so Lambda and all, person who knows AWS can do that. I myself personally don't do it, and I don't know also. Then Snowsite is a new app kind of a stuff which Snowflake has come up with. So if you see this web UI here, which I had logged in, and you will see on the top here, Snowsite. So it is a better, alternative of this web UI. So it does the same of what your web UI is doing here. Okay, but it is a better alternative because it gives you visualization also on the data. So it will create your bar charts and your histograms and your pie charts on your data. So if you fire a query on select star from customer or some table, it will give you a bar chart and visualizations also. So that is what Snowsite is basically. If I go and log into it. And right now, guys, this is in a preview stage. Okay, it is. So not exist or okay. So query produced those results. So you see this chart here and all that. Here it will give you so many visualizations, guys. So this is good for analyst people. It's nothing special. It is doing all the stuff that you will do from the conventional or traditional web UI only, but it is a much better kind of a preview that you can do. So that is what it is basically, Snowsite. Okay, and create your own data exchange, and there's data marketplace access also. So what data marketplace is, I will give you a web. When I give you a web tool, right? So there's a tab here called data marketplace. So I'll show you what this data marketplace is. Actually, we lost time yesterday. Otherwise, today I would have done the web UI tool due to my Wi-Fi issue. Sorry about that. Then coming to enterprise edition, as I said, it has a multi-cluster warehouse, which means this is possible. And if you see my account also, it is business critical, right? So if I go to the warehouses here and try to create a new one, here I'll get this option, multi-cluster warehouses. Okay, but if I had chosen standard, I would have not got this option. It would have been a single cluster warehouse only. Then up to 90 days time travel, annual rekeying of encrypted data, then materialized views you can create. Okay, then there is optimization, search optimization service. I don't know what it is. Then there is dynamic data masking. So data masking, as you guys must be aware, that when you have production data, and as a developer, if you want to access production data, you are not supposed to see certain columns. For example, if it is an account table where you have the account numbers, you have the email IDs, customer names, and all that stuff. So among that columns, there will be something which will be coming under sensitive data. So that sensitive data you are not supposed to view. Okay, so that will be in some encrypted form. So that data masking, it is possible in enterprise edition. So that is what it says basically. And obviously it's not available in standard. Then external data tokenization, I'm not aware what this is. Then this is business critical. HIPAA support is nothing but your compliance, or I think security related HIPAA support. Then PCI is your compliance related to, for example, if you are in certain regions, there will be regulations of, you must have done trainings. Whenever you join an account, your client will ask you to do some trainings, right? So in that you must have seen in the data protection and all that, there is some regulations which are coming from the governments of that particular region. So those compliance. Okay. Then you have try secure, try secret secure using customer managed keys. And you can also get AWS private link support. Okay. Then there's database failover and failback. I told you about fail safe, right? So that all starts here, which is why I had for demo purpose, if I have to choose you to show you this fail safe concept, which is why I have to take this business critical edition. Okay, and you also have to take it if you want to practice the fail safe part. Otherwise, for these enterprise and all, you will not be able to do fail safe.
So currently, Google does not have this private link support for enterprise edition, right?
Yeah, for business critical, not enterprise.
Okay, business. Yeah, business critical. Sorry.
Yes, yes. So this is directly from the Snowflake website. Okay, so I am showing it to you from the Snowflake website only. So here you can see they're not talking about Google as of now. Okay, then there is virtual private Snowflake. Obviously, as I told you, these will be your customer dedicated servers. So the EC2 instances that it procures for you, right? Each time in the background, those computers or those nodes only will be spinned up or spinned down for you. Okay. For the others, it is basically chosen from a pool. Always, it is not necessary you will get the same machine, and you don't have to worry also because it's not your headache. The management is done by Snowflake itself. Okay, guys. And customer dedicated metadata store is provided to you by a virtual private Snowflake. These things are not asked in tradition in the certifications. Mostly it's about the time travel, up to how many days each edition gives you. Then multi-cluster, which is the minimum multi-cluster warehouse support provided in the edition. And that is what is asked. And in which edition is customer dedicated virtual warehouse provided. I have seen these three questions in Snowflake. No, and all these is not much asked. So guys, I think we will stop here because the toss is going to happen now. And
already happened, Abdullah.
Oh, already happened. Okay.
Yeah, so Pakistan chose to chase.
Oh, okay. So we are batting first.
Yes.
Okay. Great, guys. So I think we'll stop here today, and everybody, whoever is cricket lover. Sorry. Yeah.
Abdullah, sir, I have a last.
We lost Rohit Sharma as
well. Sorry, what is your question? I'm sorry, I didn't get it.
Abdullah.
Yeah.
See, in terms of user certification, right? After we complete the course, how easy to get the certification cleared, Abdullah?
Yeah, it is very easy. I mean, you will not find much difficulty. But as I said to all of you, please, you need to, apart from the classes, you need to also keep referring to the documentation, guys. So there is a help here. It leads to documentation directly. Let me put it in the chat also.
Yeah, Abdullah, can you just put the PDF for the agenda that you have, right, in the shared Google Drive?
The course material?
The content, yeah. Content.
PPT.
No, the PDF you showed, right? The contents of the
Okay.
course.
This one. Yeah, this one. Okay, sure. I will put it there.
Thanks.
Sure, no worry. Okay, guys, I need to go and we will catch up next week.
Yeah, thanks, Abdullah.
Thank you. And guys, if you have any questions, please, you can WhatsApp me also. Okay.
Sure. Thank you.
Okay. Good day, guys. Good day.
Thank you.